My name is Jason Beto. I'm working on HarvestChoice's pest and disease effort. This map is pretty exciting. This map is showing the potential distribution of a wheat pathogen called stem rust. Now in 1999 in Uganda, a new strain of stem rust was found called UG99. And it turns out that most of the world's wheat varieties are not resistant to that strain of stem rust. This map is showing the potential distribution of stem rust, not the actual distribution. And what it's showing us is where in the world we might find stem rust and UG99 problems in the years to come. The typical approach is to model the pest and the plant at the same time. And that has certain advantages. But for strategic planning and making investment decisions, we need to know if an area might not have been planted because there is a disease prevalence there. And by modeling the pest and the plant separately, we can determine areas that might not be planted just because the disease is so prevalent.
It's about strategic responses. So we can go and effectively play war games. If we know what effectively makes the pest tick, we can then go and start making some informed decisions about where we might want to go and put in, for instance, some strategic control. We might know where we'd need to go and deploy resources, communication resources, to go and alert farmers to what to look out for in terms of new pests, technologies to go and actually control it.
In a separate effort, HarvestChoice estimates where in the world crops are grown, and this map is showing where in the world HarvestChoice thinks wheat is grown. This is done at a very high spatial scale. Typically we see crop production statistics at the state level, the province level, or maybe down to the district or county level. Here, HarvestChoice has disaggregated the data further and gone down to very small pixel levels so that we can see exactly where in the world wheat might be grown and other crops, and we can start to think about how that corresponds with the very spatial pest and disease maps that we're producing, with information we have on households and consumer statistics, poverty, and other variables.
CSIRO is Australia's peak science organisation, so it's a government-owned agency delivering innovative research into agriculture and industrial applications. With HarvestChoice, we're looking to develop a partnership where we take advantage of HarvestChoice's economics expertise to harmonise with our crop modelling and pest modelling capabilities. We've got crops that are shared between first world countries and developing countries. And in the first world countries, we've got a long history, for example, in the United States with maize and maize pests. So I've been able to go and tap into a very rich database, exceptionally rich database on pest occurrence and crop yields and so forth. We can really tease that apart and go and calibrate our models and validate them before we then go and start applying them off into to new areas like Africa.
When we do the math on these things, we find that 20% of the world wheat crop is susceptible to stem rust, at least because of its location. And kind of shockingly, 50% of Africa's wheat production is in areas that are favorable for stem rust. HarvestChoice is particularly concerned with smallholder farmers in sub-Saharan Africa, and the finding that 50% of Africa's wheat crop is in areas that are highly susceptible to stem rust is concerning. In some of these areas, the constrained yields have pronounced effects on some of the world's most impoverished and vulnerable citizens.
Many ecologists or pest managers carry with them some tacit knowledge, so that's knowledge that's sort of just been untapped, it's just sitting there, that they know where pests are.
In order to create our global maps of pests and diseases, we have to interview experts in the field. But up to now, that's been a very difficult thing. It involves sending out physical surveys, often to remote parts of the world, and maybe or maybe not getting the survey back. We've invented a new spatial surveying platform which we call VGET. This lets us send web links to survey respondents, and they can simply click on a map to show us where a pest or disease has occurred.
So this is sort of the equivalent of taking a virtual crayon and going and colouring in the map. That information can then get passed from one expert to another, and we can go and validate areas, sort of ground truthing.
Up to now, we just didn't have good global information on where pests and diseases are. And now we do. So we can start to think about what are the effects of these pests and diseases on farmers. Where in the world might we look to find these pests and diseases, and who's most affected?
Armed with knowledge about how much impact the pest is having under different climates, we can then go and start making some sort of broader scale assessments of how much it's worth expending on the control of pests in different areas, and that can be fine-tuned climatically.